Hello YouTube, it's been a while since my last upload, but I am back with a new action camera strapped to my body and a failed lenticular print in my hand. I want to create a new print without blemishes, so I thought what better way to test this camera than to use it to show you how I create lenticular prints. So what you're looking at now is 10 photographs interlaced into one image. And this is a lenticular lens sheet with hundreds of little ridges called lenticules that perform as lenses. And when we place this lenticular sheet on top of this interlaced image, given that it's aligned correctly, these small lenses should ideally work together to resolve what we perceive to be a single cohesive photograph from any given angle. As you can see with my previous attempts, as I move the viewing angle of the camera back and forth, it almost looks like an animated GIF made up of several frames. In fact, it works quite well as an animated GIF. But what makes these prints cooler to see in person than an animated GIF on screen is that from the right viewing distance, because we have two eyes offset in distance from one another, each eye will see a different photograph, creating a sense of three-dimensional depth in the image that you don't typically experience with the average photographic print. Obviously you can't really see this with a 2D video, but here is my attempt at drawing a diagram to try and help explain what's happening. I hope this diagram at least helps to explain a little bit more about why I'm not paid to make illustrations. So how do we turn these into that so we can make this? Well, we're going to need a few things. We're going to need an inkjet printer, we're going to need some glossy photo paper, we're going to need some lenticular sheets, we're going to need a rolling press, we're going to need some image editing software similar to Photoshop, and we're going to be using two free programs called 3Dependable and Grape. Now this is a lot of junk that we have to use, and I'm not sponsored for any of it. I'm just telling you what I'm using, and the printer I'm using is the Canon Pixma IX6820. That has a native black ink resolution of 600 dpi or 600 drops per inch. The lenticular sheets I'm using have a resolution of 50 lpi or 50 lenticules per inch. 600 divided by 50 equals 12, and that number 12 would be the maximum number of interlaced frames or photos I'll be able to resolve and display in my lenticular prints. I'm using 10 photographs in mine, so all my frames should be visible in the final result. The lenticular sheets I'm using are 13 by 17 inches. The lines or lenticules are running up and down vertically in a portrait orientation because I want to print portraits, and they come with an adhesive backing so that they can be fixed to the paper prints using the roller press. I'll link to the sheets in the description below. The paper I'm using is a very smooth glossy paper by Canon called Pro Platinum. The smoother the surface of your paper is, the better the results you're likely to achieve. Okay, so now that we have our printer, paper, and lenticular sheets, the first thing we need to do is print a calibration sheet so that we can conduct a pitch test. We need to do this because neither the printer nor the lenticular sheets may be as precise as the manufacturers might have claimed they are. What performing this pitch test does for us is provide us with a more accurate LPI count or resolution for our lenticular lens sheets, which will be a very important number to have when I go to interlace all my frames together as a single image later on. So in order to create our pitch test, we need to use a free software called 3Dependable, which you can download at 3dependable.com, and when you first open it, there's going to be a little dialog box talking about a USB dongle not being connected to your computer. You can click OK, and then click OK again because we only need to use this pitch test button at the top. First, we need to enter the LPI count that was advertised by our lenticular sheet manufacturer. The sheets that I purchased were advertised as 50 LPI, so I'm going to enter 50 for the LPI. We're going to keep the delta, the bar height, and the spacing numbers as they are, and we're going to change the resolution from 1200 to 600 LPI to match the DPI of our printer. Next, I'm going to go to image size, and I'm going to choose custom, and I'm going to change the dimensions, the width and the height, to the size of my 13 by 19 inch printer paper, which I have to calculate what that is in millimeters. And now we can click output and save our file, and then open it in Photoshop. You can see here, this is what our calibration sheet looks like. We want to print this out. and you just go to File, Prints, and I am using a glossy paper, so I'm going to go into the print settings and choose the exact media type that I have. I happen to have exactly Photo Paper Pro Platinum. We're going to have print quality at high. We're going to set it to 13 by 19 inches because that's the size paper I'm using. And we can use borderless printing, I suppose, and photo printing right there. That's all you should really need to change the settings to, and then you can hit print. And this little dialog, some clipping will occur. That's fine. We don't need it to be perfect, and it should start printing. I hope you find this video entertaining because it doesn't really get much better than this. If you are watching this video to help you fall asleep, I wish you a very good rest, and for the rest of you that are watching this video wide awake, I would recommend you take this time to read the disclaimer in the description where I mentioned that I don't really know what I'm doing and this is not a tutorial. Now that we have a freshly printed calibration sheet, cover the sheet with your lenticular lens sheet with the smooth side of the sheet facing down and the grooves in the sheet facing upwards. Align the sheet so that the vertical lines on the left are running straight up and down. Choose the number next to the bar that is nearest to being completely black or completely white. We're going to use this to run a second pitch test for more accuracy. Now we're going to reopen 3Dependable and we're going to conduct another pitch test. This time we're going to use the LPI that we discovered during our first pitch test, and we're going to enter that number, and then we're going to change the delta to 0.01 instead of 0.1. Make sure that we're using the right LPI, and then we can create our second calibration sheet. Open the new calibration sheet back up in Photoshop, print it, conduct your second pitch test looking for the number next to the black or white solid bar. So now that I've figured out the LPI resolution of my lenticular sheets, it's time to take all of these .tiff files and interlace them into one file, and I'm going to be using a software called Grape Interlacing Software by pop3dart.com. It's free. You can download it and install it for free, and I have it installed, so I'm going to open it up, and the first thing it'll ask is for a job file. It's a little .text file that saves all the information from your last interlacing projects. I'm going to start a new one from scratch. I'm going to enter 600 into the horizontal printing density and 600 into the vertical printing density. The measured pitch is what we figured out earlier with the pitch test. It's 50.26. Picture width is going to be 229 millimeters, and my picture height is going to be 305 millimeters. The margin can stay at 5. We're going to be using a TIFF, and my sequence direction is going to be left to right, as you see in this folder. The camera is furthest to the left in TIFF 1, and it's furthest to the right of the model in TIFF number 10, so I'm going to be doing left to right 1 to 10 sequence direction, and we can click submit. It'll ask to save the job. I'm not going to save this, but you can save it as a .text file, and then it's going to ask us to open up the folder where these images are saved, and mine happens to be in lenticular print. So I'm going to select that folder. It's reading the images. My file sizes are rather large, and it's interlacing, calibrating, saving, and we're going to save this back in my little folder, and I'm going to name it my interlaced.tiff. And that should create what we can now open up with Photoshop. Cancel. And there we got it. This is what we're going to print. We have our interlaced image printed now, and it's time to align the lenticular sheet using the registration marks. There are 6 of these registration marks. There are 2 on the top and bottom left corners, 2 on the top and bottom right corners, and 2 in the middle to the top and bottom of the image. there should be two straight lines on the sides of the image, one running from the bottom left corner to the top left corner, and another line running from the bottom right corner to the top right corner. When the print and the lenticular sheet have been properly registered, we can use clamps to hold them together. At the top end of the print, pull the protective film off the back of the lenticular sheet by only about ½ inch. Be very careful because once the adhesive touches the paper, it will be very difficult to get it to untouch the paper. Place this end into your rolling press. I could not afford an actual rolling press because I have run out of money to spend on this project, so I am using a cheap laminating machine without the laminating material. Whoever made this machine, I don't think they did a very good job of naming their brands. Surely there were better names to be had. Once the rolling press is pinching the exposed edge of the lenticular sheet to the top end of the interlaced print, take the clamps off. Grab and hold onto the protective plastic film that protects the adhesive on the back of the lenticular sheet so that it continues to pull off as you run the rest of the print through the press. In most of my attempts, I experience air bubbles trapped between the lenticular sheet and the print. I just use my hand to rub them out. Because I'm not using gloves, I'm going to get fingerprints on these lenticular lenses no matter what, but I've heard that you can use rubbing alcohol to remove any fingerprints from the surface of the lenticular sheet. And after using 5 lenticular sheets and 10 pieces of paper, I finally have a result that I'm sort of happy with. There is a lot to improve upon before I can make lenticular prints worthy of displaying in a gallery, but I feel like I'm on my way there. If you're still watching this, thank you. And I hope you found this video somehow helpful or entertaining. I don't feel right about selling these prints in their current iteration, but if you're interested in my work and in collecting any of my artwork I may release in the future, I'm building a mailing list that you can join for free at creative.vision/printclub.